Yep.
Okay. I'll just go ahead and share my screen then. Okay, let's get right to it then. And this is recording, okay. Everyone can see the screen, right? Cool. All right. So welcome back, everyone. Hope you had a good week. So today we're going to pick up right where we left off with the whole Python data analysis stuff. And I'm going to be taking 10 minutes to finish up my part. And then I'm going to hand it over to our data science man, Shanil. He's going to walk you through all the DS stuff. So yeah. Quick thing. I sent some exercises over, I think yesterday or day before yesterday. Were those helpful in any way? Like, let me know in the chat if you found it good, because like this is one of the things that we got in feedback last semester. It's always helpful to know whether they were of benefit to you. But besides that, let's get started. So to recall back, we imported our data set. We imported the libraries we need to process the data. The most important one being so far the pandas library. And we read our CSV file into the data frame, storing this variable df, and we renamed one of the columns from survive to label. And what we're going to do today is, what's that? Sorry, I was going to sneeze there. So what we're going to do today is we're going to show you how to switch two of the we're going to how to switch columns, like columns place. So you may be wondering why we may want to do that. Well, we're called back to when we renamed the survived column name to label. We did that because the survived column in this case is it's our column of interest, if you will. It's a real way to solution to our problem where you want to predict whether a passenger given their information would survive or not, right? So it would make sense to move this whole survive column to the leftmost, right? So the way we do that is that we use this function called list, right? And we pass into our data frame, right? And what that will basically do is that it will, sorry, I'm a thirsty boy today. So what it will do is that it will put the column names, correct me if I'm wrong, we're a little bit rusty with the exact terminology, but it will put the columns in such a way that we can like access them like as if it was an array, right? Or do you want to?
Yeah, it's just a list of the categories.
Correct. So it basically just takes your data frame and puts it in a list format, right? And why are we doing it, you may ask? Well, recall that we want to switch this what is called label now with the passenger ID, so it becomes leftmost. So intuitively, this is the 0th position of the, well, it's at the 0th index of the list, if you will, and this is at the 1st position in terms of indices, right? So essentially, what we're doing here, right? We're reassigning the column in the 1st position to the column in the 0th position. And we're doing the same thing with the column in the 0th position. We're swapping with the column in the 1st position, right? So, and then after that, all right. Right. I'm sorry, my mind is kind of rusty today. I don't know what's happening. Rakita, what does the reindex one do again? The reindex function?
I think we're just trying to like have them iterable again later when we're trying to separate out the y from the x values. You guys don't need to worry about that too much. We will get back to that. You can keep going on ahead of that, Samrat.
Yeah, so like you said, it's not that important to know exactly the exact mechanism behind it, but just know that it helps us in
You won't need it
switching
just
these
yet,
two.
but
Yeah.
yeah.
Yeah. So essentially when you do all of that, uh and by the way, we're returning whatever this returns, we're sending it to a new variable called df underscore swap. And that's really just so that we have it in a separate variable so we can like distinguish it between the old data frame and the new one. So right, I have to run everything from the beginning because otherwise it won't work. Right. And oh wait, it wasn't cereal, it was Titanic. Right, there we go. And if you guys saw a file that said Roblox, I was bored. Okay. I don't know. Quarantine really takes a lot out of you. Just give me a sec here, do that, and this should work now. Yep. And well, we don't know if it worked or not, right? So recall back from last time, what do we have to, what function do we have to use to make sure what we did actually worked? Does anyone want to take a try? Oh, I should probably read the chat too, because people are responding there. Yes, exactly. Dot head. Good job. So that what that will do, like we went over last time, is that'll return the first 5 rows. And we have successfully switched the label column with the passenger ID column. Great.
There's something blocking.
Oh yeah. Because I opened a chat, right? So that's the reason. Is it better now?
Yeah.
Cool. Thanks for letting me know. So, okay. This describe function, I'll let Shanil tell you more about it. That's more about his part of the presentation. And I believe, yeah, the last thing that we have to do is encoding, right? Not to be confused with the UTF-8 encoding, the stuff that we did earlier. So essentially, what happens is that in all these data sets, right, you'll often have data values that the machine itself can't really understand, but just by itself. So for example, if you look at this column, if you look at the embarked column, right, look at all the data values under that column. What type of variable are they in terms of integer? They're string variables, right? Or I guess code characters too. But essentially, the computer can't really understand what these mean internally. It just understands numbers really under the hood. So that presents a problem. We need somehow to translate all these data values, S, C, SS, all that stuff, to something the machine can actually understand, so it can actually process the data and make a model out of it. Or rather, we make a model. So the way we do that is a process called encoding. And encoding is basically assigning whatever data value we have already. So for example, one of them was S, right? In the embarked column. We assign that essentially any random number, but we usually start from like 0, 1, 2, 3, 4 onwards. So in this case, we would reassign S, the character S, to 0. And you'll notice once again that just like last time, when we were trying to swap the names of the columns, like survive to label, once again, we're using a dictionary notation, right? So just think of it, you often use this dictionary whenever you're trying to map one thing to another, right? Hence the name dictionary. It comes from the abstract data structure map. You'll learn about that in 132. Soon enough, I hope so. But yeah, essentially, we map each of the data values that the computer can understand to something it can't understand, which is oftentimes numbers. So S becomes 1, S becomes 0, C becomes 1, and Q becomes 2, right? And all this stuff, it looks a bit intimidating, but don't worry about it. So essentially, to access a part of our, I should mention, I forgot, I skipped a step actually. We're actually saved the df underscore swap, SWP and we made a copy of it, and we stored it in a variable called df_copy. It's really for stylistic purposes and keeping everything in separate versions of data frames so we can know if we did something wrong. So we got df_copy. It's the same data frame with all the stuff we've done.
Wait, one tiny thing.
Yeah.
Another advantage of using a copy whenever you make a big change to the data frame is a small change. You might as well like conserve memory and just have it in the same variable. But if you're trying to make a big change, like swapping columns or something like that, it's better to have a copy, because if you have to rerun a cell, then the other ones won't fail for whatever reason. You're just gonna like modularize that change to that variable.
Yep, that's a great explanation. Thank you for that. So yeah, getting back to that, we've renamed it df_copy, and the way we essentially access the data frame is that we essentially use the same notation we would to access something in a list, right? So in this case, we want to access it by the column. So we gave it the column name embarked, and we put it in those square brackets that we saw earlier, right? So we're saying that the embarked column of the df copy is equal to the embarked column after you apply some fancy magic stuff. What's the fancy magic stuff, you ask me? It's this stuff right here. It's this apply a function, and in it we're passing what we call a lambda function. And essentially, what a lambda function is something you don't really need to know. Once again, sorry, there's this car that just passed by, huge subbase. So yeah, if you guys in 132 heard of an anonymous function, I don't know if you guys done that, but that's essentially what a lambda function is. But just think of it as a way to write a function in one line like this, right? And again, it's not the main focus. Just remember that this is the syntax. This is the way it is. If you want me to go more in depth of it, just contact me later, and I'll make sure to do that. Right. So yeah, so we did all of that, and we just to run this, don't I? Okay. And as always, we have to check whether it actually changed anything.
We have a question in the chat.
Yes.
As to how the values became doubles instead of ints.
Right. That was a question that we had, actually, wasn't it?
I think that's just because Python is like dynamically typed, and somewhere there must be a single double value, so it just wanted to convert all the others into doubles as well. That's probably just a Python thing. It doesn't make a difference.
Yeah, and like I said, guys, data's never clean.
Another thing is when we pass it into a machine learning algorithm, normally we're going to send it in as a bunch of double values because we do this thing called scaling that compresses every value in a range into a finite decimal, basically. So it doesn't make a difference in any case.
Yep. And I'm sorry, Shanil, I think I've gone over my time a little bit. But
it's fine.
One more, yeah. So does anyone have any question about anything I just did? Anything at all? All right, I guess not then. So if you have any questions later, you can always ask me after the whole meeting's done, but I will pass it to my dear friend, Shanil O'Neill, otherwise known as Shanil. So take the floor, buddy. Let me just stop sharing. Yep.
Okay. Okay, so today we'll look over data cleaning and visualization. So as Samrat explained earlier, we used a bunch of imports, pandas and numpy mainly, but those ones are the most important for data cleaning and viewing what is there in the data frames. We saw the use of data frames and head right now, as well as in meeting one. But today we'll explore some other ones. So head displays the first 5 rows of the data frame. Then df.shape displays the number of rows and columns, which is the size of the data frame. df.columns displays all the names of the columns in the data frame, and describe gives a bunch of statistical details for each column, and then just prints out the data frame. I'll show you the difference between all of those and while we actually run it. That was the import statement. And if you did the exercise, you'll be familiar with the serial dataset we've been using. Okay, so this is df.head. It displays the first 5 rows. You can actually explore a lot of this, lot of the data set with df.head. It gives you a feel of what things are present. Like you can see all the columns with different values and what they can be like. But what df.head doesn't do is give you the total number of rows and columns. So we can use df.shape for that, which just returns a tiny value of rows, comma, columns. We can also get a list of all column names. So as you can see in head, it prints it out like in this format. But if we want to actually use it, we can just copy this and paste it if we want to rearrange the column names or remove some columns. So it's handy to have this around. Then df.describe. So this basically takes all of the columns and gives you the count. Count is basically the total number of values. So in this, you can also figure out if there are empty values. So if there was one row empty, this would be 76 instead of 77. Then it gives you mean, standard deviation, minimum, and all of that. Okay, we have a chat. Okay. And this is print. So why print will be useful? We can see the end of the data frame as well. Okay. And as well as we can see the top 5 and the last 5 rows. We will see why it's useful just in a second. Any questions till now? I assume not. So this is all clear, right? So in many data sets, this was actually a very clean one, but most data sets we will use will be very unclean. So they will have null values, NA values, and those are the ones you generally want to drop because a machine while training a model will not understand those values and it will just keep throwing errors. So this is what we have to take care of while cleaning the data set. You should be sure to always check for null values and NA values. And we can use the function is.null to check that, and then drop NA to remove all of the NA values in the data frame. But sometimes, yeah, sure.
Okay, just wanted to say null values are just they're caused by human tendency to try to like get through it with minimal work. If you're doing a survey, right, and then you leave something optional, very few people are actually going to fill it up, and a lot of people will just leave it as null and let it pass. But if we want to try to make use of some of those entries that have been recorded that people didn't ignore, then we have to somehow treat the other null values. If we drop out null values, we're going to lose data. So normally what they do is this kind of averaging out of the values that are there in that category, and then they try to get an approximation of what they might have said. Just a tiny interesting note on that. Back to you, Shanil.
Yeah, that's what I was saying. So we use df.fillNA, which is like if it's like values, we want to fill it with values which won't cause any problems to the model. But as Rohit said, will retain the other data which was required. So we can use fillNA, probably add 0 or something in the brackets, and all the NA values will be changed to 0. Let's see this in Colab. Okay, so the df dot is null sum, as you can see right now, is 0. That's why, just to show you all, I added an extra row which displays the NA values. See, in this case, printing the data frame can be useful because head will just give you the top 5 rows and not the last few rows. So you won't know if there's an empty row or few empty rows at the end of it. But if you do print, you can actually see some of the values. And now if we run is null, all the columns have one null value, which is right here, last row. And once we do the drop NA, it basically changes, it removes the NA values. Any questions to know? Yeah, we can use df.head for how many ever rows we want, but it's easier to use smaller ones, like use the appropriate one for whatever we need. So if we wanted the shape, we probably don't want to print the entire row, but we just, you can use something as small as df.shape, which returns only this much. Okay. And sometimes we want to remove like specific rows and columns, which probably might cause problems when we are training the model, or just they're not relevant, or we just don't want them. So we use a df.drop, which drops the entire row or column or the specific cell, even if you want that thing to happen. And to remove duplicates, we can use df.drop underscore duplicates. Okay, there's a question. Oh, in place equals to 2. Wait, I can just show you in the Colab file. So we do in place equals to 2 for a specific reason. If we don't want to change the data frame, so over here we could have done something like, yeah, if we did something as simple as this, it would have done the same. But when we do in place, it basically tells Python to put the value of like the moved after this function, like after NA is dropped, put the new data frame again in df2 and not just return the value. Yeah, like Rohit said. Yeah, if there's one NaN in a row, it drops the entire row. That's why sometimes you want to fill the NA with blank values like 0 or 1 or something, which won't cause any problem to the model, and retain the other data. Like Rohit said, some people probably don't want to fill the optional parts and just want to get through it. And I was telling all about duplicates. So if we have duplicates in the data frame, it can cause problems, because if the model is trained against the same data, let's say 5 times, then it will have a bias towards that specific data, and it will use this data to cause problems, and there'll be like false negatives and false positives all the time. So we always make sure that we drop the duplicates if there are any. Sometimes they're not. And we will see the drop function over here. Let's say we want to drop shelf, because shelf will be irrelevant when we are, let's say if we want to predict the rating of a cereal based on its nutrient values, what shelf it is placed in a store is absolutely useless in this case. And so let's say we drop shelf. as you can see, the shelf, the entire column disappears for the data frame. And we use access equals to 1, which is search for shelf in the columns and not the rows. If we do access equal to 0, it will start searching for shelf in the row, but there is no shelves in the row, so that will fail. And this just drops the duplicates, and in place again does the same thing. We probably don't want to create another data frame for this, so it just replaces the existing one with after dropping the duplicates. Any questions? Okay, let's see data visualizations now. We will use Seaborn. Last semester, we saw some of matplotlib, and Seaborn is built on matplotlib. So, and it is simpler, easier, and just better now. So, but for some cases, we will need to import matplotlib as well. So we import both Seaborn and matplotlib. And okay, so these are a bunch of plots. We will see them on Colab, but this is just a brief explanation. So count plot displays a histogram of the sum of all the rows based on column as a key. So think of it as a key and value situation. Bar plot is a simple bar plot of X versus Y. Scatter plot is also a simple scatter plot. Point plot displays a line plot. It's a categorical plot. We won't be looking much into those, but it's good to know. A heat map.
There's a question in the chat, and I think it's an excellent question, which is,
so,
will those things use an iterative process to drop these things out? Because that'll change the runtime of these methods.
We don't want without using for it's actually how pandas is written. So it probably won't iterate to the entire loop, but it just makes it simpler. And so we can use df.top. So in the case of top, it goes to that specific column because it already knows the column names, and then it just drops the entire column. And while looking for duplicates, it obviously has to go through all of these, all of the rows to look for duplicates. So it will compare row to row. So like, is row 0 equal to row 1? But then again, yeah. So we don't really need to know the process, but it's a good algorithm they've written, and it actually reduces. It's a pretty efficient algorithm is all we need to know. And it makes our life simpler. We don't have to write 50 lines of code just to remove duplicates. It's already present. They're good enough to give it to us.
I also wanted to add,
I would
it's like
like to add
it really.
something.
Oh, sorry. You can go first if you want.
Yeah. Yeah. So with all these libraries that we are using, like matplotlib, pandas, numpy, and all that, these are built on Python, and they have all these functions written in Python for you with optimized code and runtime scenarios, so that you don't have to face problems. You can focus on the core stuff and do data visualizations and data work with the data, and not focus on coding the whole algorithms and all. So that's a plus here.
Yeah, the emphasis in data science and machine learning is more on the process and the reasoning, as opposed to like the implementation, because a lot of that has been done by somebody else, thankfully, and there's a library usually to do what you're looking for.
Oh yes, you still have to do that through 216. So be prepared for another 2 semesters. Yeah, C just makes it first. You're happy you'll be doing in Java. So we were at heat map. I'll explain heat map on Colab. It's much easier with the actual graph over there. And regression plot is basically a linear regression model, but in a graph. And it's really interesting. It tells us a lot about the trends. And so most of these have a very simple syntax. If they are X versus Y plots, I'm assuming most of y'all know X versus Y in graphs. If not, I can explain. Okay, I assume you all know. So we can do the syntax is X and the column name, Y and the column name, and data is equal to the data frame name. And that basically just gives us the plot. Okay, let's see that on Colab. Okay, so this is a count plot of manufacturers. So we can see all the manufacturers over here, and obviously they're color coded, and it gives the total of each serial. Oh yes, that would be helpful. So it adds up all the serials for each manufacturer. It uses the manufacturer as a key, and the rest as values, as Samrat explained, the same thing with dictionaries. And then it plots those. We can also do something like this, where in the data set, there are two kinds of serials. One is hot, the other is cold. We can also use this to plot hot and cold serials differently. In this case, cold is obviously dominant, but in other cases, this can be very helpful, because then we can know which manufacturer makes which cereals and if they prefer any specific cereal. So, okay, so this is a box plot. If you all don't know what a box plot is, it basically has trends from, so if the data is, in the data, the fiber ranges from 0 to 14, but most of the values are between 0 to 6, as indicated in the box plot. And the blue one, the blue bars, the box, which has most of the values. So most of the values are between 1 and 3. And in this, we can know that all these values more than 8, there are 3 values. They are called outliers. So these outliers basically cause problems with some of our data sets, because they can, if they are insanely high. So if you think one of the serials has fiber of, for example, 100, and most of them are between 0 and 4. So if you think about it, the average, the mean will go up so high because of that one specific serial, and it will cause a problem in the data set. Here, you'll learn about it in SAT 400. So these are just outliers. Yeah, all you need to know is they cause problems when you're actually dealing with running statistical analysis on them, because they will just ruin the mean and the standard deviations. Okay, so we can see the box plot for sugar, which is pretty normal. It doesn't have any outliers. It is perfect. So this is probably what we want our data set to be like. So no outliers. That's a good thing. Now let's look at bar plot. So this is a manufacturer versus rating bar plot. So you can see these bars indicate the average, and these black lines indicate the range. So in, let's say, N, the manufacturer N. I'm not sure who that is, but okay. Yeah, outliers, you want to remove them. Okay, so you have to see where the outlier is, and for that you'll have to go to the data set. For example, okay, you can do it here. So you okay, this is not printing the entire thing, but if you open the data set probably on Excel or something, so you'll see where the values are placed at. Sorry. Once you open it on Excel, you can see, for example, in Fiverr. So one value is over here at 10, which is an outlier. So, and the other one's over here at 14, and the third one's 9. Okay, we are blessed. All of them are here. So we can just drop all of these values. So let's say if we want to drop so this basically dropped the first value. As you can see, the 100% bran is gone with an insanely high fiber amount.
In addition, you could also sort the whole data frame by increasing order of fiber, for
Right.
example. And you could see like the last few rows, those should have the data values that look like the outliers. That's also another way to do it.
Can I add something?
Yeah, sure.
Okay. So if you want to remove a whole row, that's fine, and people do that. You're gonna end up losing a whole, you'll be losing all the other values for the other categories in that row. And if you have a ton of data, that's fine. But if you have very limited data and every data point is valuable to you, what you might want to do is something more like assessing if it's beyond a certain number of standard deviations from the normal, and then try to bring it within a certain range that's acceptable to you, or just make it the average, or whatever rectification that you can do without losing it.
Yeah, in this case, the outliers are very few compared to the actual data point, so we can actually think about removing them. We can even leave the value of 8 over here. It's fine.
Tell them about the sugar, Shanil.
Sugar. Oh yeah, sugar. So so there is this interesting I believe it was oatmeal. Was it oatmeal? So
Yeah,
oatmeal in
one.
this data set has -1 sugar. So which is an outlier. Okay, you can see the lowest range over here is at -1. It doesn't make sense, but it is -1. So if you probably eat oatmeal, you lose sugar. But so problems like these exist in our data set. So if we want a model, yeah, it somehow removes 1 gram of sugar from your body. I don't know how that makes sense, but it does. So, but a machine won't understand that. So we can probably change the value of -1 to something like 0, because like 0 sugar is understandable and a lot of cereals have 0 sugar. So changing values like those can actually make our model more efficient and make it, okay, yeah. So it'll make it more efficient and cause and increase the accuracy, cause the false positives and false negatives to go down, and which is what we want at the end of it. So we were at bar plots, right? So these bar plots, the black lines indicate the range, as you saw on the box plots, it's just horizontal and vertical. So these ones just show maximum of these ratings exist between For N, it's like 65 to 70. For Q, it's like 30 to 55, something like that. So they just show the tens on the ratings. And okay, so this is a point plot, but okay, so in this, I'm pretty sure that you won't understand what's going on. And that's why we have to know different kinds of plots, right? So we can't use one specific plot for a lot of things. We have to use different plots for different scenarios. So these two ones are doing the same thing. It's plotting the same thing, but one makes sense and the other one doesn't. Okay, yeah, I'll go into that just a second. But so yeah, one makes sense and the other one doesn't. And I was saying that's why we need to know different kinds of plots, and we can always try out different plots. If one doesn't make sense, let's probably try a different one. Yeah, it does look nice. And so what U does is U basically assigns color to all of those. So as you can see, there are calories over here. So calories in this data set range from 50 to 160. So each of those unique values has a color. And so you can see 50 is plotted over here for manufacturer Q and the rating of 60. And yeah, this graph is not useful because you cannot make good, uh, you cannot get useful insight out of it. So we probably don't want to use such graphs. Not that point plots are bad. It's just that in this data set, we cannot make a useful point plot. Right. Okay. Any questions till now? Okay. So this is a scatter plot of vitamins against rating. So, okay, this helps you to understand a few things. First, that rating and vitamins don't really have a very big correlation. Most of the vitamins in this data set are between 20 to 40, and they have a bunch of ratings which go from, I think, as low as the lowest rating possible to the highest rating. But we know that higher vitamin cereals aren't really preferred because all of them are just under 50%. So they are the not popular ones. And so there are such insights you can gain from a data set before you train your model. So you'll understand why and what your data set is like. So if your data set is skewed towards one specific thing. Yeah. So you can understand if your data set is probably favoring more, like, let's see the sugar one. See, if it's probably favoring the more sugary ones, and if it's not, so in this it's pretty average, but you'll see there's a downward slope. So as the sugar increases, the rating goes down. So this can tell you something about the people who actually give the ratings. So do any of you have any guesses on what the public could have been?
Health conscious.
Yeah, that could be one very good answer. Sadly, I don't know what that was. We got this data set from Kaggle, but we can actually make some reasonable assumptions that we can see that, okay, Samrat said health conscious. We also know that as younger teens and infants, and like, let's say from age 5 to 15, for example, they prefer more sugary cereals like the Oreo O's and whatnot. But we see that the rating goes down when the sugar increases, which indicates that the data set is probably dominated by more health conscious people who are probably elder. So we just from this one graph, we can probably deduce that there are like, okay. Yeah, so we can probably deduce that the age group which dominated this data set is probably like 25 to 45 or something like that, like the older people and not the younger people. And and just from seeing this one graph. And we also know that this data set prefers the uh, non-sugary cereals. So this is something we need to keep in mind before we train a model, that what our data set is skewed towards. And visualizations are probably the best tool to do that easily, because they just give you one graph in like split seconds and you'll know, okay, this is going on. And like you see a bunch of graphs and you'll understand, okay, the data set is skewed towards this side. Okay, there'll be older people doing this. So we probably need to account for some other data set and probably merge two data sets of like one data set of younger people giving ratings, like preferring the sugary treats. Right. Any questions?
I just wanted to ask if anyone knows uh, what the name of what this correlation looks like. It's blank correlation. You can kind of see like it's going this way. But does anyone know?
Is it a negative correlation?
Oh, I'm sorry, I zoned out there. Did someone say negative?
Yeah.
Yeah. Yep.
Okay, that's good. And okay, let's look at the heat map. Okay, this looks very confusing at first, but it is not that confusing, but really important. So I can explain what's happening. So you see these columns listed. Okay, I can't do this. The columns listed on the left and bottom. So this is calories against calories, and this is determining the correlations between these two columns. And this is what this function does, df dot correlation, like CORR. So this forms a correlation between these two columns. Okay, okay, let's see an example of calories versus sugars. Where is it? Okay, it's at 0.56, which is very high. And you would understand, okay, as sugar increases, the calories go up, obviously. So that's how correlation works, but it is inversely proportional to fibers, as this is minus 0.29, 0.3. So, okay, that also makes sense. Like as fiber goes up, there's like lesser number of calories needed. So this basically forms this heat map, and you can find the most correlated variables. And why we need to do that is there's something called multi-collinearity while building models. So if you're doing a logistic regression, for example, most of the industry standard or most research papers, they go and they check for multicollinearity when there are like more than 10, 15 variables. And if it is more than 0.8 or 0.9, they just drop these variables because they would cause a bias when you're actually training the model. So if it's suppose fiber and potassium, okay, so most of the fiber in the cereal is given by potassium. So most of those studies would adopt this one of these variables, which is causing multicollinearity, and that's why we actually need to understand why we do this, why we are looking at this complex plot over here.
Can anyone guess what happens if we leave them in there? What might happen when the machine learning model starts to predict and it sees something is that highly correlated? What might happen? I think it's a term that we briefly discussed in the previous semester. If you don't know, that's totally cool. Going once. Perfect. Good stuff.
Okay.
Yep.
Yeah.
That's it. So it'll basically identify, hey, look, this is the answer key. I don't need to look at anything else. And I'm just going to go with whatever this particular value is every time because it's just leading me to the answer in this data set. But that's a problem when in the real world you deploy it and it, the data isn't exactly the same as the one that it trained on. It's going to perform horrendous. And usually the accuracy drops very much because of that when a model overfits to the training data. So that's important.
Interesting fun
Yeah,
fact about that
that's-
is like
Yeah.
for the COVID-19 vaccine efficacy, there is a difference between the data in a trial, like in the controlled trial samples, and the real world, efficacy. So like typically what the scientists are saying is that there tends to be higher efficacy in the vaccine trials when it's in a controlled setting, and there's actually a slightly less efficacy when it's put out in the real world because there's so many different factors that the controlled environment didn't account for. So yeah.
Yeah, this is why it's very important. We don't want a model to fail just because of overfitting. So if we have enough variables, we can afford to drop a few and not lose any accuracy and not lose our model not knowing. So yeah.
And if you look in this particular heat map, you can see that the color key is such that the black, as soon as you get blacker squares, you get a more negative correlation. So if you look at the blackest squares in the heat map, the ones that jump out at you immediately doesn't be the ones that have the most negative correlation. And as it so turns out, it looks like the ones that the black squares are usually the nutrition facts that are like, unhealthy, like calories and sugars is another one. And yeah.
Yep.
Yeah, so the black squares are actually inverse. So over here, when we saw calories versus, we saw sugars versus rating. So we can actually get more insight from this. So when the sugars increase, the rating goes down. So it's like a negative black square. And what we saw over here, so as the sugar increases, the rating comes down. So there's a lot of insight from this one specific heat map. We don't need to know all of it, but the most important is that we drop the multi-collinear variables so that our model doesn't overfit.
Yeah. Shanil, can I take a quick second
Yeah.
to answer that question there? How do we prevent the machine from making the mistake of overfitting?
Or we drop the variable.
That's again a very strong option when you have a lot of
Yeah,
data.
when you have more than 10 to 15 variables.
But what we could do to preserve the value of that data, right? And I'm you might have guessed, I'm someone who likes to like preserve all the information possible legally. So you try to add some sort of scaling to it. And normally, suppose the other variables have a range between 0 to maybe 10 or 100. And this one has a range between 0 to 100 as well. If you want to give it less importance in the machine, then you would just scale that value down, multiply it by like 0.05 or something, and make that value less important as it goes into the machine. Another thing would be to try to minimize how many times you train it so that you catch it before it starts to learn the pattern. So it does a good job with the data and does a correct fit instead of doing an overfit. So you minimize the training cycles. All right, there are some statistical questions that you guys might want to.
Yeah, so it is calculated. Okay, I can give you probably a very simple example. So if you see rating versus sugars, over here it's minus 0.76. So you see a slope going down over here, right? Okay, there's a better graph for that. So this is rating versus sugars. I'll just use this graph for a second and explain it. So there's this negative slope going over here. And that negative slope is basically that value. So it is minus 0.76. The value of the slope is this.
Remember that equation in high school you used a lot? Y equals mx
Yeah.
plus b or c, whatever you use. That's m. That's the value of m right
Yeah,
there.
this is the simplest way to explain. It's much more complex than that because they use a very accurate way of getting those values, but this just explains it in the way we can understand. Does that answer your question? Cool. Okay, so this is a linear regression plot. Rohit will talk about linear regression in the next meeting, but so this is a very useful plot. Actually, this is better than the scatter plot we saw over here. It gives us more insight. Like this line actually gives us that, okay, for sure it's a negative slope. And the light shade you see next to it is just a second. Okay. So the shade you see next to it is actually the model. So this is actually running a linear regression model and then plotting it. And this is the extent of the model. Like you can say probably like the model is predicting these ranges. So when you say there's like 0 to probably there's a -1 over here, right? So 0 at 0. So this is from 55 to 65. That's the range. Yeah. And there's also a plot with fibers. And over here, you can see the actual problem or the outliers cause. So you can see an increasing slope, but actually, like if you disregard these 3 points, which are outliers, you will see it's actually a pretty messed up scatter plot. And there is very less correlation. Like there's fiber and rating is weird. There is no uh, increasing trend. It's just these outliers are causing it for the machine to think that, okay, there's an increasing threat 10 just because at 5 or 14 there's like a 90% rating and 10 there's like a 60% rating. But if you see between 0 to 6 where most serials are, it's just random. The ratings go from anywhere between like 10 to 70. And it's just that's why we have to like remove these outliers, otherwise they'll just cause a few problems. Any questions on the last two graphs, or actually any?
And I think that was great on time. It's 6:30 on the dot.
Yeah, I'll just finish that.
Yes,
Yeah, I
statistics
was
is
telling you
very
all
important.
I couldn't find the right point plot for that serial data. So this is a point plot I found online on the US Census data. You can actually see it on the slides later as we are running out of time. So just a review of what we did today, we used head, shape, describe, print to view data frames and all the different uses and why we use 4 different things for the same thing. And checking for null empty values, then deleting null empty values or replacing them, like replacing them with probably just a random 0 or actually scaling them as Rohit said, or and deleting those columns using DOP, then plotting the data set using Seaborn, all these different kinds of plots we saw and their uses. And the why is very important. And we looked through it actually the entire lecture, not a lecture, actually meeting. So just a second. So we talked about how outliers are important and why we should remove them and the problems they cause. In the last graph, we saw that. And why outliers can also cause overfitting. We also got to see why we use different kinds of plots and why we use plots entirely, like what's the need of visualization, right? But it can give us so much better insight than just looking at the data and trying to understand, okay, this range is from, all we can see in a Excel sheet is, okay, this range is from 0 to 20 or 0 to 30. But when you compare it with something like rating or something like that, and it actually helps us identify and reach our final goal, which is get a model to train a model to predict the rating based on these nutritional facts. And I think Rohit will cover some of the why next week as we are running out of time. Are there any questions?
Hey, you guys are free to. Oh, wait, Shanil, do you want to share the form before they go? If they
Oh
have to?
yes.
This next thing I wanted to show is optional, and it
And-
depends. It depends on.
Yeah, there are a bunch of resources in the slides. I'll put the PDF after this meeting, and the Colab file is in the drive. So if you go to BigTh AI, it's in Pioneers, and it's right over here. If anyone wants to review it, but just please don't edit.
I think editing's off for.
Is
people
it?
or
Okay,
numbers.
great. Yeah, okay. You can run it and you can make your own copy and run it or edit it how much you want. Right.
Do you want to send them
I'll
the
share
form?
the, yes.
Okay. All right. So while he does that, if I don't have permission to give me. All right, you know what? If I do have permission to share your Turpmail ID, potentially, just give me like an emoticon thingy on your Zoom window. Kind of like
Wait,
that.
do you mean UID or email? What?
Like the Turpmail ID.
Oh, okay.
No, you don't need to share it. I have some info from last semester that I want to share. If you don't, well, I need to know who's not comfortable with that.
Okay, can anyone else put the link of the form in the chat? My thing is not loading.